Hi, now we are going to start mechanics of fluids, or previously we heard or we have studied mechanics of properties of solids. Now mechanics of properties of fluids we are going to talk. Mechanical properties of fluids. First term we are going to talk is thrust. In solids, we spoke about force. Now it is replaced by thrust. Same meaning. Force acting perpendicular to the surface. This is a surface. A force is applied exactly perpendicular to it. That is called the thrust. Straight. Next, pressure. General formula for pressure is force per unit area. This is fluid pressure. So fluid pressure will be thrust by area. Instead of force by area, we are writing thrust by area. Meaning is same. Force applied perpendicular to the surface in which it is taking place, divided by the area. Lesser the area, more the pressure. Density. Mass by volume. Mass experienced. Suppose you are taking a liquid in a container, the mass of the liquid divided by the volume of the container. That is called the density. Density of water is fixed 1000 kilogram per liter. It is a constant value. It's fixed value. Mass per unit volume, we call it as density. So basic concepts. Next, atmospheric pressure. Liquid pressure. Atmospheric pressure means, for that we should know the basics of equation for pressure or pressure experienced. Pressure gets exerted by a liquid. Definitely, you are going to consider a container because liquid does not possess any shape. It possesses the shape of the container. So, up to this, you have the liquid. I am taking a small column here of height h. The area of this is capital A. So, fluid pressure is thrust by area. Thrust is nothing but the force. The force experienced by the liquid in this area. General formula for force is MA. But here it is considered to be the weight of the liquid. The force is nothing but the weight. So I can write here mg by A. So P is equal to mass is volume into density into gravity by A. Volume is area into height into rho into G by A. A cancels. You will get pressure is equal to H rho G, height of the liquid column into the density of liquid column into the acceleration due to gravity. This is the expression for pressure exerted by a liquid in a container. So anywhere if you want to talk pressure, hereafter you talk in terms of H rho G only, where rho is the density. How to calculate atmospheric pressure, sir? Formula is same. H rho G. Atmospheric pressure means height H. 76, when it open a barometer and keep it outside, the height experienced by the mercury level is 76 centimeter of mercury into density of mercury is 13,600 into 9.8. You multiply. So you will get pressure P is 1.013 into 10 power 5 Pascal. 1.013 into 10 power 5. You multiply all these three, you will get the answer 1.013 into 10 power 5. Now, liquid pressure. That liquid pressure only we have seen. Value, H value 76 centimeter, rho is 13,600, G is 9.8. Atmospheric pressure H rho G. Liquid pressure means what liquid you are taking, that density, what height you are taking, that H value into G. So basic formula for liquid pressure also it is H rho G. Pressure exerted by liquid or liquid pressure. Pressure exerted by liquid column. Anything you can say. Column of a liquid you are taking. So pressure exerted by liquid column also you can take. Buoyancy. Buoyant force. When a solid is immersed inside the liquid, any solid, partially or fully immersed in the liquid, the upward force experienced by it, you call it as buoyancy. The upward force, we call it as buoyant force. Downward force, that is called the weight, you know. Upward force, we call it as buoyant force or force of buoyancy. Okay. Archimedes principle. Whenever a solid is immersed inside the liquid, definitely the liquid will displace. The solid appears that, say for example, initially it is W weight. When it is immersed inside the liquid, it appears there is some loss in weight. That is called apparent weight. So that apparent weight of the solid which is immersed is equal to the weight of the liquid displaced. Very, very famous Archimedes principle. Okay. So the apparent loss in weight, what the solid is experiencing when it is immersed inside the liquid, is equal to the weight of the liquid displaced. The same thing only we are talking in laws of flotation. Law of flotation, same concept. The weight of the liquid displaced is equal to the apparent loss in weight of the solid which is immersed in the liquid. The center of gravity of the solid and the center of buoyancy, these two lie in a same line under this condition. Same line. That is law of location. Fine. Next, Pascal's law. You imagine a rubber ball. You are putting holes at equidistant at different points, and you have injected the water inside. Now you are pressing the rubber ball. When you press the ball, what will happen? Water will come out equally from all directions. Water will displace equally in all directions. Pressure exerted by the liquid is same everywhere. That is called Pascal's law. When it is at rest or when you apply a pressure, when it is going outside, the pressure is equally distributed. Simple concept, Pascal's law. When the fluid at rest or when the liquid is at rest, fluid means the liquid flow of something is called a fluid. Liquid and gas. Major difference is liquids cannot be compressed, but gas can be compressed. When you compress a liquid, liquid will come out. The gas can be compressed. So flow of a liquid or a gas, we call it as a fluid. We have two applications in Pascal's law: hydraulic lift and hydraulic brake, which is using Pascal's law. Hydraulic lift, hydraulic brake. We will see hydraulic lift working here. Similarly, Pascal's law principle is applied in hydraulic brake also. Okay, hydraulic lift. You consider a U-tube of irregular cross-sectional area. Here, the object to be lifted is kept on the other side, second limb. First limb, you are applying a force. Assume the area here is A1 and here the area is A2. Liquid is there throughout. Liquid is present. When you press or compress on one side of the limb, that means you are applying a downward force. The liquid is getting compressed. Through the other side, it gets lifted up. When it is coming up, here you are keeping the weight of the object to be calculated. So that object also getting lifted. So by Pascal's law, pressure on the left hand side is equal to pressure on the right hand side. Pressure at end A is equal to pressure at end B. End A, what is the pressure? Force by area, F by A1 is equal to pressure at end B, W by A2. W you have to calculate. A2 by A1 into F. A2 by A1 into F. So knowing this area, pi capital R square, pi small r square, pi cancels, R2 capital R square by small r square. into the force what you are applying on the left hand side limb. You can lift the body and you can calculate the approximate weight of the body which is getting lifted. So this is the application of Pascal's law. Hydraulic brake using in four-wheeler. It also follows the principle of Pascal's law only. Okay, fine. Next. Another important property of the liquid is viscosity. Viscosity is liquid friction. Normally, when a body is moving in a surface, there exists a frictional force. So, viscosity is nothing but liquid friction. Suppose this is a tube through which liquid is flowing. Any two layers you consider, the distance between the two you call it as dx, area A. The force experienced between the two layers is proportional to the area between the two layers. It is directly proportional to the difference in velocity. Central layer possesses maximum velocity. Then it goes on decreasing, dV by dx. F proportional to A into dV by dx. Or F is equal to constant eta A into dV. This eta is called coefficient of viscosity of the liquid. Eta, coefficient of viscosity. So eta is equal to F by A divided by dV by dx. When you want to define eta, you make the right hand side denominator unity. Right hand side denominator is dV by dx. Let it be 1. Area also will come a denominator, 1 meter square. Then I can write coefficient of viscosity is numerically equal to the viscous force between the two layers having unit velocity gradient. Unit velocity gradient means dV by dx is equal to 1 per unit area. Unit of eta, dimensional formula of eta. Calculate the dimensional formula for force, area, velocity, and distance. Rearrange, you will get ml power minus 1, t power minus 1. Unit kilogram, meter power minus 1, second power minus 1. If you know the unit, from that you can write the dimensional formula. M, L power minus 1, T power minus 1. So this is the basic concept, introduction of viscosity, otherwise known as liquid friction. When a liquid is flowing through a capillary tube in a burette, we have a burette. End of it, a capillary tube is attached. Full of liquid. 0, 5, 10, up to 50 cc. So the volume or quantity of liquid flowing per second, the amount of liquid coming out is called volume. Coming out per unit time divided by time is proportional to three quantities. Number one, it is proportional to viscosity of the liquid. It is proportional to pressure gradient. Pressure gradient means pressure by distance. The distance is nothing but length of the tube here. So V by T proportional to viscosity and proportional to pressure gradient and proportional to the radius of the capillary tube in it is coming out. Longer the length, it will take more time to come out. So only we have put this in denominator. Using dimensional method, we are going to solve this equation. Left hand side dimensional formula, right hand side dimensional formula. Equate, you will get the answer as is equal to viscosity. So viscosity is equal to constant K, that is pi by 8 P R power 4 by L into V. That is eta is equal to pi P R power 4 by 8L. Pi P R power 4 by 8L. V is the Poisson's equation. Dimensional formula of left hand side, dimensional formula of right hand side, you can equate and finally you can get it. Very simple, most important 5 marks. Viscosity exerted by the liquid. Stokes law or Stokes formula. You consider a long, tall glass jar having castor oil inside. Castor oil. This is lead shot. You are dropping a lead shot inside the castor oil. The velocity in which the solid is moving inside a liquid, we call it as viscosity. The force experienced is viscous force. It is proportional to the viscosity of the liquid, the radius of the lead shot which is moving inside, and the velocity known as terminal velocity. Up to few distance, you leave it. Then only you have to start your time. Because to reach the terminal velocity. So F is equal to constant K eta or V, that is 6 pi eta. So this is the equation for viscous force. When a solid is moving inside the liquid, the force experienced by the solid inside the liquid is given by viscous force. F is equal to 6 pi eta AV. Reynolds number. Reynolds number. When a liquid is flowing in a tube, Reynolds number only determines whether it has reached the critical state or the body is moving within the critical state. Rn is equal to rho Vd by rho density of the liquid, V velocity of the liquid which is flowing, capital D What is capital D? Diameter of the tube. This is eta, the viscosity of the liquid. So up to 2000, 0 to 2000, any value you will get what? Streamlined motion. When it exceeds 3000, turbulent flow. So in between streamlined flow and turbulent flow, the Reynolds number value is 2000 to 3000. How it is possible, sir? Some cases it is accelerating faster, some cases slow, some cases nil. So streamlined flow or turbulent flow between 2000 and 3000. Beyond 3000, it is turbulent flow. Below 2000, it is streamlined. Correct, Anna? Final topic, Bernoulli's principle or theorem, anything you can take. Three forms of energy we have. When a liquid is flowing through a tube, three forms of energy. Two already we know. Pressure energy is a new one. Potential energy and kinetic. Potential energy, kinetic energy, pressure energy is a constant. P by rho g plus V square by 2g plus h is equal to constant. P by rho g plus V square by 2g plus h. You have excellent derivation for that. Bernoulli's theorem. Very, very important question in the mechanical properties of fluids. Bernoulli's theorem. Okay. Thank you.